Hey everybody, Mrs. Bianchi. We're talking about a new probability game called Over the River, the Marble Edition. Now, it's my hope that you've already played Over the River with the dice and that you played Over the River with the integer chips, the red and yellow chips, because playing those games first will really help you understand a couple things that we're learning about probability and learning how we're using data displays to help us with our strategies. So the situation that we have here, the container that you see in the image there has 10 marbles in it. And we have at least one of each of the following colors. So red, blue, yellow, and green. There are 10. So there's at least one of all those colors. So to play the game, you have to kind of predict, like, do you think there might be the same number? Well, there can't be the same number of each marble, right? Because we have there's 10 marbles, and four is not compatible with 10. So we can't have one of each color. But you might speculate that there might be, more red or whatever. So you place your markers. Now, if the color comes up, then you're going to cross it over the river. You can only cross one at a time. Now, what we're going to do to help us organize our data is we're going to keep a tally. So we have the 10 marbles. Each time the marble is randomly selected, we're going to record the color on the tally chart. Now, just so you understand how to make tallies, because I always am surprised that we have sixth graders that don't know how to do this. To make a tally, each time something comes up, like if it comes up once, twice, three times, four times, and it comes up a fifth time, you go like that. So that would be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That way it's easier to kind of count up your groups. So 5, 10, 15. All right, so that's what tally marks make. Now, once we have our tallies, then we're going to total them. We'll find the fraction equivalent, the decimal equivalent, the percent, and then it should help us to make some predictions. All right, so I'm going to go ahead and pull some random. I'm not going to tell you. I'm going to pull random. I haven't even seen the container, but I'm shaking them up. All right, and that time I got a red one. So what would we do? We would put a tally under red. Red, tally 1. I put the marble back in the container, by the way. I'm going to draw again, and I pulled red again. So that's so far 2 red. Pull again. Red again. All right, now if the game was going on, then if I had each time red came up, I would cross it over the river. So it came up 3 times, I would be able to cross those over the river. But so far, these other colors, which are blue, yellow, and green, have not come up. Let's go back to our game board. Whoops. All right, so I'm forgetting, I think we had 3. For some reason that didn't stay. All right, so let's go back into the marble container. I'm going to pull another marble. And red again. All right, so that's 4 red. Keep pulling. Ah, another red. So 5. Red again. Red again. Oh my goodness. Okay. Shake them up. Ah, new color. We finally have something different. We have green. Again. Red again. Ah, yellow. Tally. Ooh, blue. We haven't seen it. Doesn't look blue on the screen, does it? But it's blue. It actually looks kind of green on the screen, but I can assure you it's blue. It's blue, so let's mark that. Yellow. All right, so it's always a good idea if you're doing this in class to have someone keep track of how many total pulls. If we count how many total pulls, so we have 7 here, that would make 8, 9, 10, 11. So let's go to a 20 and it'll make more sense why in just a moment. So that's number 12 is red. This is pull number 13, red again. Pull number 14 is green. Pull number 15 is yellow. 16, red. This should be 17, blue. Again, it doesn't look blue, but I can assure you that it is. So let's just make sure we didn't go over the 20. So we have 10, 11, 12, 13, 14, 15, 16, 17. 3 more pulls. blue, red, and one more pull to make it an even 20, red. All right, so this is 3. Here we have 12, 3, and 2. All right, so the fraction equivalent, this would be 3 out of 20. This would be 12 out of 20. And we can simplify that, but we're going to leave it unsimplified. 3 out of 20 and 2 out of 20. Now, if your class did more polls, because what I usually recommend is trying to go to 50 if you can, and if you have a lot of time, going to 100 is even better. All right, so what's the decimal equivalent of that? Now, we should be able to use equivalent fractions because decimals, remember, is we can do it out of hundredths. So it would be 20 times 5, that would be 100. So 3 times 5 would be 15, and 15 100ths easily converts to 1500ths like this. All right, here if we convert this to 100, 20 times 5 equals 100. 12 times 5 would be 60, and 60 100ths would look like this. This out of 100 would be times 5 to get that. This times 5 would be 15. And then again, out of 100 times 5 times 5, this would be 10. 10 100ths would look like this. Now, remember, if you have all of something, that would be 20 20ths. So if you add up all the green numbers, it should be 20 20ths because that's the whole thing. And if we add up all this, the total number of poles was 20. Now, if we add up all this, it should theoretically equal the same thing as this, which is 1. So if you were to add this plus this plus this plus this, it would equal 1 or 1.0, same thing. All right, so now as a percent, this would be 15%. Because 15 over 100 easily convert. This is 60%. 15%. And 10%. All right, now we can use math to actually figure out how many marbles there are. Because 15% of the marbles we pulled were blue. So let's just use a calculator to kind of speed things up. Our total number of marbles was 10. And the decimal equivalent of 15% is 0.15 or 1500ths. So that would suggest that 1.5 marbles are that color. 1.5 marbles would be that color. Now, since I'm just going to put that number here, but we have to round. Now that would mean the same thing for this, right? 1.5, but we can't have a half a marble. So we have to decide which one. One of them is going to be 1 and one of them we're going to round up. All right, now what about 60% of 10? 60% of 10. If we find that, 60% of 10, so that's 10 times 6/10 or 600, that would be, let's clear that, 10 times 0.6 equals. So that would give us 6 marbles, right? 6 marbles should be this color. All right, and what would 10% of 10 be? 10% of 10. So one way you can do that on the calculator, even though I don't think you need a calculator, there are 10 marbles, and 10% is equal to 0.1, and we get 1. So we'd expect 1 marble to be that color. All right, now keep in mind, we know that there's 10 marbles in the container, and 7 of them are already kind of spoken for. So we just have to make a judgment call on which one we think there might be more of. Now, if we had pulled more, we would have been more confident in which one was probably the bigger number. So let's say you want to say that there's 2 that are blue. So see, that makes 8, and this makes 9. So we have 1 more to be 10. So that could be your potential guess. Now, when you're playing the game, you don't know how many blue there are, how many anything there are, right? But you can use math to really get a good idea, especially if you have a lot of pulls. The more pulls you have, the closer the percentage of the number of marbles you have will actually give you the actual answer. Now, if we look in the container, So if we're playing the game, you don't know how, the more you play the game, the more confident you are, because you kind of got the idea that red was one of the ones where we had a lot. So if I was playing this game, I think I'd put a lot of markers on red. We had a couple that didn't come up too much at all. So we might put some on green. You'd have to decide. But let's actually reveal. Let's do the reveal and let's look at the math. I'm going to show you how many there are, and I'm not sure if you're going to be able to tell, but let's do the reveal. So if we look careful, it's probably going to be better if I put them in my hand. Let's look at what we actually have in the container. So here are 10 marbles, and as it turns out, we had 3 that were yellow, we had 1 blue, we had 2 green, and 4 reds. Now, so our math was a little bit off, but I can assure you that if we had done 50 or 100 pulls, and we did the math on that many pulls, then the numbers would be pretty. In fact, I don't think I've ever done this with 100 pulls where the numbers that we did were not exactly what was in the container. So statisticians use this idea of sampling to get a good idea of how many people are watching a television show, or how many deer are in the pine bush. We use this idea all the time. So we did a small sample. The larger sample you use, the more accurate your data is to the actual larger sample. All right, so kind of an interesting way to look at probability. If you're playing the game, hopefully you were able to use your tallies to kind of quickly figure out. If we did a dot plot on this, or a graph, this was graphs that we did before in class of what numbers came up. Now, unfortunately, the colors didn't match the marble colors are down here, and I couldn't get it to sync with the tool that I was using. But hopefully you've enjoyed playing all the various games that we played in class to help introduce the idea of probability and statistics and data displays.